Hello everyone. In this presentation, I will be discussing the current management of Balcombe Creek and its catchment. I will be using data collected by myself and my team in the field to draw conclusions on waterway health and the effectiveness of current management strategies. From the research I have gathered and data collected in the field, I will make recommendations on potential improvements that could be made to strategies to address issues in waterway health. I will begin with an introduction to the catchment and the stream's physical characteristics. So Balcombe Creek is part of the Bunyip River catchment, which is displayed on the right. The Bunyip River catchment is one of 4 major catchments in Victoria. It has an elongated shape extending from the Mornington Peninsula up into the southeastern suburbs of Melbourne. The catchment has an area of 4,078 kilometres squared. Balcombe Creek itself is an intermittently opening estuarine creek, which flows into Port Phillip Bay near the township of Mount Martha. The creek is part of the Balcombe Creek Reserve, which maintains significant native riparian vegetation with dense covers of swamp paperbark. The creek appeared to have a very slight slope as flow at all 3 of our sites was minimal. The map on the left of this slide displays the land uses surrounding Balcombe Creek. As you can see, there is significant urbanisation in the area, signified by the dark pink zones. There is also major livestock production in the area, signified by the blue zones in the upper reaches. The nature reserve surrounding the creek is signified by the light orange zone. The image on the right is a satellite image of Balcombe Creek with the location of each of our 3 sites marked. Site 1 is in the upper reaches of the creek, in the Briars Wetlands Park, which is signified as a tree nursery or green zone. Site 2 is further along the creek, downstream of Nepean Highway, with natural riparian vegetation in the immediate area of the creek, however, in close proximity to urban areas as signified by the purple zone. Site 3 was located in the Balcombe Creek Reserve as seen in both maps. At each of our sites, we collected data on water quality with the results displayed in this table. When comparing our results in accordance with the State Environmental Protection Policy for Waters and the Australian and New Zealand Environment and Conservation Council, we found that the dissolved oxygen saturation was much lower than the minimum standard, which recommends that dissolved oxygen be at a minimum saturation of 70. And as displayed in the table, all of our 4 sites were below 40%. Our measurements for conductivity were also not within the SEP guidelines, as the recommendation is below 500 and all 3 of our sites were above 1,000. The rest of our findings were within guidelines, with pH, turbidity and nutrient levels all within normal range for highly modified urban areas according to SEP Waters. We also collected macroinvertebrates at each of our sites in order to gain further insight into stream health in accordance with the rapid bioassessment methodology. The presence of certain macroinvertebrates can help determine levels of stream pollution depending on the tolerance levels of the macroinvertebrate families found. We calculated signal values for all of our sites, and as displayed in the table in the top section of the slide, and found that the stream was inhabited mostly by tolerant water fauna. As the table on the bottom of the slide shows, the signal values of each of our sites indicate that there is a moderate pollution in the stream across all sites. Overall, our findings show that Balcombe Creek seems to be in relatively good condition, with some issues in conductivity and dissolved oxygen, and the presence of predominantly dirty water fauna. The high levels of conductivity could be explained by the fact that the lower reaches of the creek are an estuary. However, the conductivity or level of salinity increases as the sites move upstream, as seen in the graph. This could be a result of dissolved salt ions entering the stream as runoff from stormwater sewerage pipelines and livestock production areas nearby to sites 1 and 2. The high conductivity could also be the reason for the low dissolved oxygen levels. When the temperature of the water is too high, it can reduce the dissolved oxygen, but at all 3 sites, the temperature was around 15 degrees, most likely due to the canopy preventing excess sunlight penetration. Phosphorus was within SEP Waters guidelines, but its presence could also be further indication of runoff from agriculture entering into the stream. The signal scores of our macroinvertebrates also indicate the stream is moderately polluted on a more long-term scale. The low signal scores could be a result of the turbidity, which, while within guidelines, was still very apparent and can cause issues for clean water fauna, whose gills get clogged by the sediment particles in the water column. The low signal scores could also be a result of the low dissolved oxygen levels, which have a huge effect on fauna respiration, according to the RBM. The stream is currently managed by Melbourne Water, who work with a number of organisations to monitor and protect Balcombe Creek and its catchment. In this slide is a summary of the Mornington Peninsula Shire Council's Integrated Water Management Plan, which covers the catchment of Mornington Peninsula. The plan is a comprehensive framework which covers many aspects of water management and includes numerous strategies to achieve outcomes for the community and environment. There is a strong emphasis on climate change and the challenges it will bring for water supply and environmental health. For the purposes of this presentation, I will focus on the environmental aspects, which is seen in outcome 4, healthy and valued waterways and marine environments. And the key strategies they are going to use to achieve the outcomes for this are reducing the flow of stormwater runoff by encouraging infiltration and stormwater harvesting, reducing stormwater pollutants and load entering the waterways and bays, continuous Indigenous vegetation buffer along streams, and promoting sustainable water management in farming. Melbourne Water also have a specific management plan for Balcombe Creek itself, which is summarised here. The objectives of this program include water quality, healthy estuarine riparian vegetation, tidal exchange, estuarine wetland connectivity, and recreation and access. The actions they are proposing to take to achieve these goals are reducing threats from invasive species, the production of educational materials for the community on weeding and revegetation, and the protection of Balcombe Creek within the reserve. To conclude the presentation, I will summarise the effectiveness of the current management in regards to the data we found and make recommendations for potential strategies that could be implemented. So from our data, we can see that the protection of Balcombe Creek in the reserve is highly beneficial to stream health, with most of the key parameters within the guidelines, and it has also helped to maintain a mostly unmodified riparian zone full of native vegetation. We can also see that other objectives such as recreation and access have been maintained. However, there are still certain issues with the stream, such as indicators showing that nearby agriculture and urbanisation is having an impact on the stream. There is also significant erosion resulting in highly turbid waters, which, as discussed, could be affecting the fauna. In order to address these issues, I would suggest strategies such as sediment traps being put in place and planting more native vegetation upstream in order to prevent erosion. The planting of more native vegetation could also decrease runoff and in turn decrease the effects of nearby agricultural and urban factors, such as sewage pipelines and roads. I would also suggest that all roads that are unsealed be sealed. Berg, one of the key groups that involved with the management and observation of Balcombe Creek, has also made similar suggestions. This would help to decrease the conductivity of the stream and in turn increase the dissolved oxygen, which would have numerous benefits for the stream health.